Hello and welcome, or welcome back to another episode of Whether or Not. I am Stella Q, and like you, when it comes to the weather, I like to order just the facts, thanks, with a side of the whole truth and nothing but the truth. Well, as it happens, so does my friend Jeff, who utilises his ex-Navy meteorological forensics skills in a most pragmatic fashion to delve in and deliver just that, the truth, based on hard evidence. It's his thing, and I just like to tag along and ask questions. We do a deep dive on the skies and delve into the depths of the atmosphere to unravel what is truly behind some of the serious events that, somewhat unfortunately, will never leave us high and dry and wanting for content. That's what we aim to bring to you, the truth. There's plenty of weather forecasters out there, and we are more weather backcasters, if you will. This episode, we are going to dissect the recent intense thunderstorm event that ripped through Texas on May 16th, 2024, claiming 7 lives, destroying infrastructure and winds that blew out windows and twisted structural steel as if it was fuse wire, and leaving millions without power for some days, which was somewhat hellish in the heatwave that shortly ensued. Understandably, there is always speculation surrounding these events, which is healthy. It's always good to question what is in front of us, so that's why we're here. Let's dive in and explore this together. Was it weather or not? And hey Jeff, how you going?
Going good, Stella. How are you today?
Very good. Houston, Texas. What say you?
What say I?
Yes.
I say I'm going to present the meteorological perspective today and look into one aspect of geoengineering to either rule it in or rule it out as being a factor. And I'll show a whole bunch of weather charts and satellite and radar data and all that type of stuff to give you the meteorological view.
Excellent. All right.
Okay, so on May 16th, Houston was pummeled by a major storm with destructive hurricane strength wind, and a tornado, I believe, was spotted northwest near a town called Cypress. There was major rainfall, flooding, damage to skyscrapers. At least, I saw one report of 4 people died, and I've also seen up to 7. One report said 7 people died. Was it natural? Was it geoengineering? I'll present the meteorological side of the equation and share what I found on the cloud seeding end.
Yes, meteorological forensics is our job, and we're going to look pretty deeply into this and try to dispar some of the myths and figure out what the heck happened.
Okay, so I want to start out with a little bit of a definition of air masses, because what we have happening here is a clash of air masses. Right off the start, an air mass is a large mass of air in which the temperature and humidity are the same. So what that means is the air mass eventually takes on the characteristics of where it is. So I'm going to show a map of what that looks like, where those source regions are. Air masses at the top says they don't just sit still, they move. When they move, they change the weather in the area they cover. So in this particular case, there's the United States. You have 2 designators, 2 letters, a small lowercase first letter and a large case second letter. MP is maritime polar, which means it comes from over water. A is Arctic. C is continental polar. And then you got on the Atlantic coast, maritime polar, maritime tropical coming from the southeast, maritime tropical coming from the Gulf of Mexico, continental tropical coming from overland Mexico, and maritime tropical coming from, say, Hawaii or southwestern off of the coast.
Mm-hmm.
So when each of these air masses collides, you have things happen, and that is called a front. So what happened here was a cold front. I'm actually going to go over that in just a second. I want to go back one screen and go and show you a screen of Venture Sky showing what air masses I'm talking about. And I alluded to one being continental polar, which is up here over Montana. And then you have the Gulf of Mexico, which is maritime tropical. So I'm just going to click through this thing slowly. I've started it a couple days early. Let me go a little farther back.
So what date was this Texas
So
storm?
that was the 16th. So I'm going to start a week earlier just to show you how the movement of the air is.
Yep.
So I'll just do like one screen for each day. These are like, I'll say 8 a.m. in the morning to start the day. You can see north of Texas, you have a lot of much colder than normal temperatures, minus 12 below normal. So I'm just going to click through a day at a time just to kind of show the overall picture right here. That's dropping to the south. Now it's over Colorado with a high pressure center over Colorado. On the 11th.
When you say minus 12, sorry to interrupt there, Jeff, are we talking Celsius?
Oh, I have it set for Fahrenheit. I want to
Fahrenheit.
change it.
Okay, good. Thank you.
You know what? I'm going to just leave it at Fahrenheit.
Yeah, I think so.
Remember that. So
Yep.
12 degrees below normal over Colorado, New Mexico now. This coming up on the 12th. That colder air is moving into northern Texas. The 13th, it passes through to the east. And then you have modified temperatures again back to near normal over Texas. Coming up on the 15th right here. You can see it's actually warmer than normal. And the reason for that is the strong flow coming off the Gulf now. You can see those wind barbs showing that warm air moving up, and they're starting to interact up over Oklahoma.
Okay,
Then
I see
comes
that.
the 16th. On the 16th, now that colder air has dropped farther into Texas, and the maritime tropical air has dropped a little bit farther south, but they're intersecting now over eastern Texas. I guess that would be near, or western Texas, that would be near San Antonio or Austin. And then if you click your way through 3 hours at a time, you can see that colder air comes farther down towards Houston.
Oh,
And
wow.
this is already 2 o'clock in the afternoon, and now you're showing purple. Purple is 27 degrees below zero or below normal versus over northern Mexico. That air in the southern part of Texas is 10 degrees above normal over water, 4 degrees above normal. So this is the setup of two air masses colliding. So now I'll go back to the front and to cold fronts. And I'm going to go ahead and just start to play this. I think I'll take the audio off and play this, and I'll stop it. So a cold front is depicted on a weather map with blue teeth, cold air. And you can see it's moving towards the warmer air and undercutting it because it is denser. That undercutting pushes the warmer air up, and that warmer air holds more moisture. So it starts to rise, forming deep clouds.
Now,
And
can I ask a question here?
sure, yeah.
The cold air is denser. Is that because of the moisture level in it?
That's part of it. Yes, because when you add moisture, it holds more, but you have to have more heat to hold more. So it's like chicken or the egg, but they work together.
Right.
Moisture, warmer air is more moist, and it's also because it's coming off the Gulf, and that continental polar air was coming off of land, which means it's dry and it lost its moisture over any terrain. So they're showing a cumulonimbus cloud, which is a thunderhead. So it depends on the stability of the air on how much thunder you're going to get, if any. And later I'll show a radius on from that area. And in this case, they show a squall line sometimes comes
Wow.
through if it's a fast moving cold front. You get those strong lines of thunderstorms and really high winds. Do not want to do that.
No, not a good idea.
You don't want to be that pilot. So that kind of covers what I wanted to show about cold fronts. It causes the lift. Cooling causes, or lifting causes cooling. Cooling causes condensation. If it condenses to 100% humidity, then you get rain. And as that layer gets deeper and deeper and deeper, you get bigger rain and hail and whatnot. Collision of two different sets of properties with two different types of air masses. So I want to go back to, I don't really need to go more into that one right there. So first thing I investigate after looking at the overall picture like that is flight radar. I wanted to rule out or rule in the possibility of an aircraft doing seeding operations.
Okay.
So when I look for that, I go to this property, this Ventu Sky, to find out the temperatures, because we're looking for -10 for iodine cloud seeding. So the temperature, your Ventu Sky has all these choices over here. And typically in the wintertime, at least in California, you're around 8,000, 10,000 feet, 12,000 feet. But being that it's coming into summer, 18,000 feet gives you a temperature of about -6 over Houston. So you'd have to go up another few thousand, or another 1,000 feet or so probably to get to -10. That's the sweet spot for seeding with silver iodide.
Right. So that's the correct temperature required for the seeding to take place. Right.
Right. It's the best -5 to -10. I most frequently saw closer to -10 when I was watching the cedars this winter. So jumping
and
back
of course, those temperatures will vary from day to day as to what height that you would have to go to get to them, correct?
That is correct.
Okay.
So it depends if a cold front's coming in, if it's already passed. Once a cold front comes through, that level drops. There's a very specific time for cloud seeding. There was plenty of moisture on this day, but what I did was I went back to 1950 Uniform Time Zone, UTC, which would also be called Zulu, which is London time. I went back 2-3 hours prior to that storm hitting Houston and looked at this area, which spans Houston to the south right here. You see it with the cursor. Farther over to the left is Austin and San Antonio. Dallas is up at the very top, right beyond the Flight Radar 24 emblem. And over to the right, you got Baton Rouge, Louisiana. So that storm ultimately went from almost at its most extreme width to pretty much where to the west of Houston, all the way to Baton Rouge, this line of thunderstorms. So what this is showing right here, I just clicked on that one particular aircraft and I played this through at faster speed, 20 times speed, so I could watch it in not real time, 20 times faster than real time, looking for any aircraft that flew through that area. And then I click on it and I watch it to see if it does circles. And I didn't find a single aircraft that was doing that. Most were going not north, because that would have been going right into that storm. They were going sideways when they did it. So this particular aircraft, if you look at this chart, speed and altitude graph.
Can we zoom in on that a little bit, Jeff?
Can I zoom in? Let's see. View, zoom in. So this guy leveled off at 20,000 or 21,000 feet. I got to point out that I set filters for 15 to 21,000, and particularly looking for one aircraft, the King Air type of aircraft, which does all of California's seeding. So I'm looking 3,000 feet below that level and 3,000 feet above. If an aircraft pops into that range, it shows up on this chart.
I see. So you've just filtered out for that little section of those aircraft that are going to be in that area at that height.
Correct.
Yeah. Okay.
makes it possible to actually click on each one. There were probably only 20 aircraft that flew in that 5-hour period preceding um, the event where it actually came in. So,
right. So there's only about 20 that could have been candidates.
Correct. And like if you just look at this guy, you can see it moving slowly. I could move it faster, but like if I were to click off of that one and then pick another faster speed, somebody else is going to pop up in a second. And you can see the timer's clicking up pretty fast. Anyway, did not find a single aircraft that was willing to go into that teeth of that monster. Right. Kind of doesn't make sense why anybody would. And it is summertime and a lot of rain's coming, and they knew it. So why would you want to cloud seed that? Cloud seeding was not an option here. So I'll move on to the next graph now and want to show you quickly that the forecasters knew this was coming. I went back to the oldest version of the area forecast discussion, which is the detailed thing between forecasters, between forecast offices that shows their meteorological reasoning. It gets pretty detailed, but if you just look at the bottom part right here, long term, Thursday through next Monday. So this was, a couple days before. This was Tuesday, issued at 1:20 p.m. They're looking at the long term and they're talking about this already. It won't exactly be the best day to be National Barbecue Day. Heavy rainfall event for Southeast Texas. This was seen in the progs, and the forecasters were talking about it well before. Right. If you continue to go closer down, like into the 32nd update prior to the current day, they start talking in more detail, and they're saying this is not going to be great. Once you get into the 31st prior forecast, and these are issued like 6 hours apart, they get into even more detail. Which one? I think it was maybe 29 that gets into,
every 6 hours they do this?
Pardon me?
Every 6 hours they release one of these reports?
Yes. And that's every major forecast office. So, there's probably 20 across the United States. I'm not sure, but they're talking about, right here, as indicated by recent meso-analysis, environmental conditions approach remaining favorable for both heavy rain and severe storms, abundant moisture, precipitable water of 1.8 to 2.2 inches, ample instability with huge values of this 4,500 joules per kilogram shows a lot of energy, fast lapse rates, which means the temperature cools really fast, which means it's going to be really unstable. Mm-hmm. Everything was there for bad things. As such, we continue to keep a close eye on the radar over the next 4 to 6 hours. Thunderstorms should become widespread over the next 1 to 2 hours as the complex pushes from the northwest to the southeast. It's coming and they know it. And now I'll go to the satellite photos. So Houston's down here. The blue is the moisture coming off of the Gulf. And this might not play very well because it's a large file, but I'll try to just step it through and show the movement of that, this cloud mass. So this yellow indicates thick high clouds, ice. Thin high clouds are red on the edges of it. Low cold water is blue. There's no snow in this picture. Glaciating cold is the green. So this is a major, that's the cold air. This is the front between those two air masses. So I'm just going to try to step it through a little bit right here. And
it's a major chaotic front. Yes, two fronts meeting.
Yep.
Wow.
It's a cold front coming between, and it's not stepping through very well. Let's see here. I'm going to have to just try to refresh it really quick. It's locked up.
It's amazing to see it like this. It just really puts things in perspective when you can see it over a period of time. It's very clear.
When this works really nicely, it works beautifully. But you can even see there's shadow effect right here because the sun's directly overhead. This is still kind of midday. You can see the shadows those clouds are producing.
Oh, right. Yes.
Let me try to play it right here.
Wow. That's a pretty solid mess.
Just too much data. I'm going to
Yeah.
go ahead and look at a different view. So this one's less data required. So you can see this shows the temperatures of the tops. So minus 40 is really important for cirrus forecasting and contrail forecasting. Minus 40 is the number you look for. And as you get to the blue, light blue, it's minus 45, minus 50 when it turns dark blue, minus 60 is where it turns blue to green, and minus 70 is where it turns from green to red. And what that tells me is this: I can look at radiuson data and see what height that corresponds with. And this is the temperature scales across the bottom. There's minus 30 is this line, orange, minus 40, 50, 60.
Okay.
Minus 70 is up really, really high above, 15 kilometers. The tropopause is right here where it starts to warm up. So these clouds, this little dashed maroon line shows that when you lift any air in this area, it is going to be warmer than the surrounding air
Right.
on either side of it, quarter mile, half mile away, if that area is lifted. And if the air is warmer than the surrounding air, it's less dense, therefore it will continue to rise. So this is telling us that the lifting condensation level is about 1,000 meters. Lifting by convection, convective temperature is 94 degrees. And if it hits 94, those clouds are going to go up until the temperature of that lifted parcel equals the surrounding air. That's up above 40,000 feet. Those tops are going to go above 40,000. And what I actually found out was they went closer to 50,000. And
right,
okay, so this is another view on RAM Slider that shows cloud top heights. And it shows that those are between 14 and 15,000 14 and 15 kilometers. So that's in the mid 40 to 50,000 foot range. Just another confirmation that that's a really, really big cloud vertically.
right. Yes.
Okay. So any questions about the satellite photos that show that system just on the verge of Houston at 2230 UTC?
On the 16th.
On the 16th, correct.
Okay.
So I'm going to move on to the next chart, unless you have any more questions, Stella.
Not at this point. You're
Okay.
explaining it very well.
Okay, so now we see the radar, and it shows the wind flow off of the Gulf, and it's showing the actual radar picture. This is at 11 a.m. prior to it getting to Houston. You can see there's like a circulation center over here where the hand is over by San Angelo. And I'm just going to step my way through this, but it steps 3 hours at a time. So there it's pushing close to Houston at 2 p.m. Pacific time, which would be about 5 p.m. Houston time. And it's just getting to the outskirts. And you can see it runs from almost from Baton Rouge, Louisiana, almost to San Antonio. So it's not a small mass.
No.
And if I step one more time, now it's in Houston. This is 5 p.m. Pacific. That would be about 8 p.m. No, 2 hours. 2 hour difference. 7 p.m. right over Houston. This is when the tornado happened. And supposedly northwest of Houston was the neighborhood the tornado happened. They were getting 100 knot winds, 100 mile per hour winds.
Wow.
It blew out windows and skyscrapers, obviously toppled a lot of trees. I mean, it was pretty bad. The satellite at that time, let me see if that looks significant here. This is not as good of a satellite picture, but the important thing here was that the wind speeds were pretty strong coming off the Gulf. They were all converging in the Houston area. And when you have winds coming from different directions, meeting in the middle, they have to do something, and the air was really unstable. And I should show that right now.
So it just sends everything into a vortex.
Pretty much, yeah. It has to go somewhere. It can't occupy the same space. So if it's unstable, it naturally goes up. And as I indicated earlier, this red dashed line tells you that when you lift the air, and it's lifting because of not so much terrain in this place, but the heat of the day, warm, moist air coming off of the Gulf, it's already unstable. This diagram right here shows that it is unstable, as indicated by this area, showing that it's warmer than the surrounding area when you lift it. And if I go to windy, this shows the same thing. This is Lake Charles, Louisiana, which is the closest to Houston. Corpus Christi would be another, but this is showing that there's a strong flow off of the Gulf with it's very moist air because of that, 80-degree water out there and land temperatures of 80 plus. So this kind of replicates on the right side the mechanics of how this figures out where that positive energy area is that's going to make thunderstorms up to 40,000 feet, which that's 200 millibars. Pressure is about 40,000. And, we're talking pushing 50 according to that satellite. So I'll move on to the next frame now.
So I gather that's quite unusual then to get to
50,000 is not super unusual in the summertime. I mean, it is still, it's spring and it's just a big storm. It's a big cloud. So, and it's because of this clash of the cold and the warm. And if you look at the anomaly on the temperatures compared to normal, one side is 13 degrees below, and over towards the western edge of near Austin, 7 degrees above normal.
Right.
Off of the water, 3s and 4s. So that's just a clash zone.
Yep.
So the thing now is, do we want to consider other things like NEXRAD? Jim Lee did a great video on NEXRAD recently, two-parter over at Climate Viewer. And he
climateviewer.com.
Climateviewer.com. Yep. So if you want to get into that, I don't buy that NEXRAD does anything like that. I don't believe in the manipulation of weather by NEXRAD operators. I don't think anybody has the power to push and pull rain sideways. They can't bless an area with normal rain and punish another area at will using EMF energy. Weather extremes, they're always going to happen, and it happens based on that interplay of the atmosphere. It's fluid. The sun drives everything. First of all, it causes the currents that cause the winds, causes the vertical motion where that air has to be replaced. There are the David Keiths and the geoengineering companies that get to play around the edges of natural weather, no doubt. That's what they're trying to do. There's HARP, which was designed for heating of the atmosphere, the upper atmosphere, the ionosphere. There are cloud seeders, and the military does carbon black for messing with clouds. Hard to catch in the act. I've spent a lot of time on it. If they're doing straight line flying at 30,000 feet and a KC-135, and there's compressors and pumps and all that stuff, that's another thing. But in this case today, where the cloud seeding would happen, it wasn't happening. I just maintain that the sun drives everything, and the jet stream is running farther north and farther south than normal. And especially when it locks in place in a position, you're going to get abnormal conditions for prolonged periods of time. That's a weather extreme that does damage to crops and floods and droughts and all that when that happens. So
Yep. So just going back to the NEXRAD thing, it appears that a lot of people seem to be blaming NEXRAD, and they're saying, if you join them all up together. But just me coming in from the cold, learning about the weather, I have already sort of started to realize the concept of how much energy would be required to have a lot of influence on these huge these cells, or even creating them. And the next rat is it's just not that powerful, is it? It just doesn't have that kind of power. It's not what it's made for. Would that be a fairly accurate assessment?
I think so. Jim breaks all those things down on his 2 videos
Yeah.
where he talks about watts. It's like the equivalent of, for that short duration pulse that it does, it's designed to have an echo off of something and come back and measure that echo. And it's not
Yeah, they're
designed
just a
to
measuring tool,
push.
really, aren't they?
Yes, it's
Yeah,
a reflection it's not pushing anything. I defer to Jim's knowledge on that, and
absolutely.
plenty of detail there if you want to watch his videos.
Yes, so Climate Viewer channel on YouTube, or go to his climateviewer.com site and you'll find everything to play with in there.
So what I maintain is it's about this. Solar cycles. A lot of people have not heard about those. So you can see right now they're numbered. We're in solar cycle 25 and it's peaking. And that red line is the forecast. So about 6 years, these are 11-year cycles approximately. By 2030, there's going to be virtually 0 sunspots. And if you go back to 1960, you could see there's been a downward trend. So the next one is going to be even lower, and the next one even lower than that. And every time we get to the farther we get down to 0, the fewer the sunspots there are, the more extreme weather is going to get. That's what I believe it
Okay.
is about. It's a 400-year cycle.
All right. Couple of questions.
Okay.
Where was cycle number 1? When did that start?
Let me see if I can get back here. Probably 20 or 11 times 25, about 300 years
Yeah, I
ago
should
is probably
just
where
get
they
a
went.
calculator. Answer my own question.
Yeah, this is somehow, and I can't tell you how they develop this.
All right.
Pretty amazing what they do, though.
Yeah. Okay. So the sunspots themselves, now, when you say they're diminishing, can you sort of expand on that a little bit? Why would they be getting smaller, and how does that why does that have a chaotic effect on our weather?
Well, when the sun affects magnetic fields, the Earth's magnetic field and the sun's, they have interplay, and we saw it with the aurora just recently. Much farther south than normal, but it
And
does affect the
farther
weather.
north as well, in the south?
Yeah, farther south and north for the southern hemisphere as well. Correct. So I think it worked equally well in both directions. The northern lights and the southern lights were way more significant than normal at a location beyond where they normally go.
Are you
Um,
able to explain why that is the case? Why are the lights being pushed further out of place,
uh,
so to speak?
it has to do with the strength of the Earth's magnetic field. I can't get too into it right now. I didn't prepare for that. As
Okay,
far as,
that's all right.
I just want to give kind of a big picture thing.
Just
We
thought I'd
could
put you on the
possibly
spot.
do another show on this at another time, but
Yeah.
I want to just kind of set up for another possible time where there's something called the Maunder minimum. This is 1645 to 1715. The sunspot activity waned really a lot, and I have another chart, so I've got these links for you guys. It was called the Little Ice Age. Maunder minimum coincided with the coldest part of the Little Ice Age between 1500 and 1850 in the northern hemisphere, when the Thames froze during the winter. Viking settlers abandoned Greenland. A whole bunch of very disruptive things happened with the Earth's climate at that time. And if you look back to another chart right here and another link, which I've also included, the Maunder minimum was that period of time right there, as this decreasing sunspot activity continued to affect the climate of the world.
Right. So as the sunspots are diminishing, it's getting colder. So
Correct.
it's not global boiling at all.
It's quite the opposite. So
Yeah.
I found this author on a nice, really good paper from this Dr. Valentina Zarkova. She talks about that large cycle along with the small cycle. And if I just quickly jump to the conclusion at the very end, this period started in 2020, will last to 2053. During this modern grand minimum, one would expect to see a reduction of the average terrestrial temperature by only 1 degree. That's a lot. If you're in a northern climate, it might be enough to affect a crop cycle.
Yeah.
During the periods of solar minima between 25 and 26, and we're peaking on 25, 26 would start around 2030. And then 11 years later would be the middle of 26 and 27. So she's saying between that period of time, 2031 to 2043, the reduction in terrestrial temperature during the next 30 years can have important implications for different parts of the planet on growing vegetation, agriculture, food supplies, and heating needs in both the northern and southern hemispheres. Expect more extremes into the future.
Yeah.
Is the bottom line.
And there's not a whole lot that everyone can do about that. So I don't know why they're trying to block out the sun, because that's going to make things even cooler.
They're doing exactly the opposite they should.
Yeah, funny that.
So
well, that's an excellent paper. All these links will be in the show notes or description. Anybody would like to go? I
provided everyone to you, and yes. I want to push this. Put a plug in for this paper right here. This is a blog called the Electroverse on Substack, and this guy talks about the extremes.
What's this gentleman's name?
His name is Cap Allen.
Cap Allen.
CAPALLON.
Electroverse Substack.
Electroverse Substack, and I think I've also given you that link. But if you just browse these right here, the titles: Winter Prolonged in Alaska, Australia's Cold and Snow, Chile's weather agency got it dead wrong as South America freezes, Frozen Turkey, rare May snow hits South Korea, cold front to drop snow on Aussie Alps. On and on and on, you have things that are leading you towards colder. And the recent floods that happened in Brazil is a very similar thing. You just have cold Antarctic air pushing way up up north of Argentina, and it's interacting with the tropical air that's advecting in from the Atlantic, and they've had a lot of rain because of it.
Yeah, that's been really bad. So it's just like any cycle. It's sort of, just the momentum, I suppose. It's that we see naturally. It's just things getting, small, and then they get big, and then they start getting small again. I mean, it's just a natural cycle, isn't it?
Yes.
We just happen to be in a very chaotic sort of end of one. Is that right? And it's going to become a little bit more chaotic before it gets better.
We have quite a few years ahead of us. If you're lucky, you miss it. Like California this year, mild, beautiful winter, perfect amount of rain. I mean, it's just dependent where that jet stream shifts to.
Yep.
And if it parks in the wrong time, in the wrong place, to give you what you're not used to, and the plants where you live are not used to.
Yes, it might pay to have a greenhouse or a glass house or something.
Probably be wise.
If possible. Grow food. And just as we were about to release this episode into the wild, another storm cell developed over the very same area on the 28th of May. So we're going to take a really quick look at that one and draw some comparisons. Texas has been pummeled yet again with something extremely similar. Jeff, what are we looking at here?
This is a humongous cloud mass in northern Texas near the Dallas area. That's about daybreak this morning. You can see it's still dark, as indicated by the red color of the clouds at this point. And the next frame, you can see the sunlight's coming back up and starting to show the actual clouds in their colors, which color scale is on the bottom, showing that the low clouds are in blue, thick high clouds are yellow, and the ice clouds are red at the edges, the high thin cirrus clouds. So it's showing that air mass is moving to the south, and
With
pretty much
that's very similar to that other air mass we were looking at with the shadow.
yes, almost identical.
It
It's
is.
kind of freaky. That was on the 16th, so
Mm-hmm.
what, 12 days
We are
ago.
now on the 28th, by the way, 28th of May, 2024, as of recording.
Yep. And if I just let this loop progress, you can see the movement towards the south, towards Houston. And at around noontime, it hit Houston again. And of course, it's going to lock up on me right now. There it goes. And it pushes offshore in the early afternoon hours or mid afternoon hours, Houston time. So it went through, and there's a National Weather Service report that was post-event. Well, that was interesting. That line of thunderstorms started out near Dallas early in the morning and became stronger, 70-mile-per-hour winds, quartered a golf ball-sized hail, 300,000 people without power, rainfall 2 to 3 inches per hour, flooded roadways, severe thunderstorm watch has been canceled earlier than expected. But it went through and did its damage.
Wow, they've certainly been pummeled. I wonder if, is this going to become like a regular occurrence, or is this sort of a mid-season change thing? What's happening, do you think?
It's still officially spring, so you have that cold air coming down from the north yet. And in this case, I'll show you the, let me back the radar off first. I have at 6 a.m. in the morning, the radar was showing up near Dallas. And this is all a clash of the air masses again. And as you push your way through the day, that shows the radar motion going out into the Gulf of Mexico by mid-afternoon. And the temperatures that cause all this are located here with, go back to 6 a.m. in the morning.
Are we talking Fahrenheit or Celsius here?
Today I have it correctly in Fahrenheit, so
Okay.
it's a lot easier to see the differences when the numbers are bigger. So you can see it's temperatures in the 60s at 6 a.m., except down closer to the Gulf. So as time goes on, you can see the distinction between the yellow and the red. I'll have to slide that up as it pushes to the south. These are 3-hour increments in time. Anyway, that distinction is up north of Dallas or south of Dallas, and it continues to push farther south as the day goes on. And by noon, which would be 2 p.m. Houston time, I think it's pushing Houston at 12, which is 2 p.m. Houston time. It's hitting Houston. So that's the differential between the air masses.
Mm-hmm.
And we could see the humidity is really high down here.
Yes, I noticed a couple of people that I know in the area were talking about the horrid humidity.
Yeah, I've seen those reports over the past few days. Some people were mentioning it in the chat as well. And anyway, basically just a battle between the air masses is what we have going on there. So
clash of the masses.
And then
almost sounds like the Mad Max of the weather.
Here you could see it's down into Louisiana at this time.
Wow, look at that.
And there's more of them firing up out to the west of Texas, western Texas. So
there's more to come, is there? Is that what you mean?
Yeah, these guys are still developing, but they're lined up to where they're not going to come through Houston again. Okay. I did look at flight radar as well. And just to make sure there are no crazy pilots going out cloud seeding, I watched.
We must do that. It's very necessary.
From early this morning, like daybreak, I went through and looked at that same levels as the other day. When I go to look for that minus 10 degrees Celsius, I got to flip over the
minus 10 degrees Celsius being the perfect cloud seeding scenario, correct?
For silver iodide, that's correct. So if I go to that chart right now, I clicked it over to Celsius, so from Fahrenheit. So it was at 18,000 feet the other day, -10.
Okay, so you
And
look for that temperature and then you find what altitude that temperature is at.
that's correct. And
Okay.
in this case, happens to be 18,000 feet, which is the same as it was the other day. And you can see all the values here from Dallas all the way down to Houston is in that -12 to -10 degree temperature range. So that's the area that I looked at. And I looked at this whole area from, Austin is over here somewhere, San Antonio right here, lower left, Houston right here, Dallas up here. I was just watching this whole area for that entire period of time. And
Right.
there were aircraft in there, but none doing circles, none doing loops.
Okay, so nothing suspicious that could possibly be cloud seeding, intentional cloud seeding?
That's correct.
That word
So,
intentional is very important,
yes,
apparently.
I think you're going to have to edit that part out. Yes.
Oh, no, I don't, because that's what they're talking about with all these bills that they're bringing forward about no intentional weather modification, etc. So, it's a very
True.
important word. But maybe I will.
So there weren't very many aircraft flying through this, as you would expect. I mean, at that moment, there's a count of 3 in that entire picture between 15 and 21,000 feet. They're mostly getting out of the way so that their aircraft don't get destroyed potentially by
Yeah,
the gust front of the thunderstorms.
right. Of course. Yeah, I guess that must happen a lot. If they're already up in the air and they know this storm's coming, well, I suppose they already know it's coming well and truly before they get up in the air. But if if that happens, what do? Do they just fly? Do they have to change their course to fly around it, or do they go higher to get over it, or what do they generally do? Or does it vary, I suppose?
No, you don't go over it because, well, here's an example. This is showing that the cloud top, the top of those huge storms.
Okay.
So that's 15 kilometers. That's 50,000 feet. No
Oh,
small aircraft is going to fly there. I mean, you don't have the Learjets that carry the elite from place to place. They fly at 45,000. They have to go around that. That's topping out at 50,000.
right. Okay.
You
So
don't
they're
fly.
generally way above all the commercial flights.
Yeah, they're most commercial flights are 35,000, give or take 5,000.
I think they call that the elitosphere.
Exactly. They're up above us, the
Oh, yeah.
CEO class.
In their own little minds.
Yep. So yeah, when you see that cloud, you go around it. Nobody directs you into it. You don't go over it. You go
Mhm.
around it.
Right. Okay. And what about the commercial flights that are much lower? They same scenario, I suppose. They just go around it,
Yeah,
do they?
you're not going to fly into the middle of that cloud because I can show you here.
So they have to have enough fuel to cater for these possibilities,
Yes,
I assume.
exactly. So if I look at like the radius data for Corpus Christi, and I do the stability thing that I do without explaining how it happens right here. Radisson is a weather balloon that you hear
Yep. Yep.
about. They're launched twice a day at most major airports.
Yep.
But what this is showing that if I lift that parcel of air, that green dotted line means at about 7,000 feet, that cloud's going to form and it's going to have huge instability because when you lift the air with a frontal surface, for instance, or by convection, if you lift it and it becomes warmer than the surrounding air, it will continue to rise.
Uh-huh.
So what this tells you is uh, the top of this, okay, on the left side is the millibar value of 1,000 at the bottom to 200 at the top. At the top of this is 46,000 feet. And when I drew that little green line that I did right there, it's taking you above 46,000. It
Mhm.
intersects way up here, which means that cloud is going to grow until it gets into the troposphere, leaving the troposphere, crashing through into the stratosphere because it's so unstable. The stratosphere is a very stable area, and typically clouds don't go there, but thunderstorms can poke through if they have enough inertia. So in this case, those cloud tops that we're seeing on this show the whole maroon colored area is in the 15-kilometer range, which would be 45,000 plus, pushing 50,000 feet.
Right.
Pretty thick storm from 5 to 7,000 foot base up to 50,000.
Yeah, okay. That's quite a front. Hence the shadow.
Correct. Yeah, just a huge unstable air mass. And this chart shows that as well. There's the 15-kilometer mark in red on the left.
Okay.
And that unstable area goes all the way up to that.
And how does this compare to, on average to normal years this time of year?
Typical.
Yeah, okay. Typical. All right.
Yeah, you get these storms every once in a while. I mean, all it takes is a cold air mass coming down and intersecting with that warm, moist air mass. So this is not unusual. It's called Tornado Alley. So it happens
okay, but the
every year.
severity perhaps is more, maybe not quite as usual. I mean, we don't see Houston being ripped apart every year, so it's just the severity, really, isn't it?
Yeah, well, there was a tornado on the 16th. That increases it, and I didn't hear that there were more than one, but I know the winds were pushing 100 miles per hour in that area.
So because of like we went over with the solar cycles, we're in number 25 at the moment. I mean, we've already covered that this could be getting worse before it gets better because of the cycle, yeah?
Yes, you have that terminating solar cycle 25, which would be in the next 5 or 6 years, just prior to 2030. And decrease in number of sunspots increases the meridional tracking of the jet stream, which means farther north and farther south, meaning that you bring colder air farther south to where it dips to, and it brings warm air farther north, which both are disruptive because it's not normal as we
It's
are
a clash of the masses.
Yep. So that huge sine wave type of a situation that you get, just for the fun of it, let me look at Venture Sky into the future and just look and see what we have coming up as far as what I'm just trying to explain right there. Picture's worth a million words. Mm-hmm. So this is the 300 millibar view, which is 30,000 feet. I have this on, it's the 28th. So this red outlines the jet stream.
Yes.
That's 90 knot plus at the center of that maroon colored area. So in this case, that hand kind of obscures the value. It's 110 miles per hour or thereabouts. But every time you have a big ridge like this, you're bringing colder air from down farther south and bringing it way up to the north. And then when it turns to the south, it's bringing colder air down farther to the south. Yes. So you have another example right here, a huge ridge, cold trough of low pressure. And if I looked at the temperatures on this, you could see the differences in temperatures. Let me look at 200 millibars. Everything's kind of grayed out. You have to look closely at the numbers. That's a minus 43 up in the Gulf of Alaska. So down over Texas, you got minus 55s. And in this ridge of high pressure, there's some minus 60s. What I'm looking for is, so the numbers are reversed. A minus 51 is warmer than a minus 60. You got to think of it because it's negative.
Yep.
So it's closer much colder to zero up here than it is down here where the high pressure center is. Mm-hmm. So it's just showing you that there's a big disparity in value of the temperatures. And then when you have that swing in the jet stream, things get out of place. And let me look a couple of days forward here.
It reminds me of a slithering snake, the way a snake moves, isn't it? I mean, it's very similar.
Yes. Oh, I had prior to this looked at a little bit forward for something else, and Look at the size of this ridge of high pressure going through the center of the country.
Yeah, wow.
And what that does to temperatures on the surface, when I look at temperature anomalies, that results in an area of really high temperature on the surface.
Hmm.
And where the air is flowing to the south,
This is
that's
2 meters on the surface, is it? Am I
correct,
reading
2
that right?
meters
Yep. Okay.
anomaly from normal. So that cold air being dragged down on the east side of that high pressure center that I showed, the winds are coming down like this from Canada. It's bringing
Yeah.
that cold air 10 degrees below normal for that time of year on the
Yep.
7th of June. And hot here under the ridge, cold here in the trough. That's
Okay, so we're in the future, and this
right.
is what's coming up.
Correct.
And purple is not good. It's like Prince says, purple rain,
Purples, yes. That's minus 15 range.
purple hail.
Yes.
Batten down the hatches, Texas. It's not over yet.
Pretty much. Get used to the extremes. They're coming.
Yeah. Well, I guess people will learn to adjust. They always have. They just got to be conscious of it.
Be
Nothing like a bit of
prepared.
distraction to get people's attention.
Yeah,
Well,
this is a good warm up for what we have coming in the future with these extremes that we're experiencing.
yeah. All right. Well, I guess we'll just be keeping an eye on what's happening because that's what we're here for. That's a little bit of an update for Texas currently. We are now at the end of May 2024. We'll keep an eye on what's happening in this area and all the areas generally, globally, because we need to investigate all aspects of these events, whether they're man-made or natural due to cycles. It's pretty volatile out there. But, I think we've come to the conclusion that this is a natural weather event occurring due to extremes, which are going to become more extreme. Fair assessment?
Perfectly said.
All right. Thanks for that update, and we'll talk to you again next episode on Whether or Not. Thanks for joining us. Thanks, Jeff.
Thank you very much, Stella.